This is the Calc 1 lecture on optimization. This section is about how to optimize something, which means how to maximize or minimize some part of something. So please take just a minute and pause the video and read the 3 examples listed. All right, let's look at the first example. What are the dimensions of a rectangle with a fixed perimeter having a max area? An example of something like this would be, what if you had a certain amount of fencing and you are trying to make cages for a zoo where you need to keep 4 animals separated, and you were trying to use whatever amount of fencing you had and make this dimension here the largest possible, because you guys do agree that using the same amount of fencing you could probably draw something that looks like that. So the whole thing is, or even longer, but you get the idea. You've got some set amount of fencing and you are trying to get a maximum area. What's the size of the most profitable production run? We're going to talk about that. That's a business application. What's the least expensive shape for a cylindrical can? So in other words, do you make it tall and skinny, or do you make it short and fat, keeping the same amount of volume? Now, optimization, because we know how to find a horizontal tangent for a particular function by differentiating it and setting the numerator equal to 0, calculus is going to let us figure out answers to these types of questions. And again, these occur in things like physics, business, economics. So let's look at our directions for how to solve optimization problems. We've talked in class before about how you need to read a problem multiple times, not just once before you start working on it. If you recall, we have often spent time answering questions like, what do I know, what do I know, what do I know, what do I know, exhausting everything we know about the problem until finally asking ourselves, what do I not know? In other words, what am I trying to find? Drawing a picture is self-explanatory. Introducing variables, you need to understand what every variable you write in your down for your problem is and what the 2 variables are in your function that you're going to write, because this is what you will have the most problem with. Writing an equation for the unknown quantity in a single variable. So in other words, you are writing a function like f of x in one variable. One step that they left out, step 4.5, you're going to take the derivative of the function that you set up. You're then going to set that equal to 0, and when you have solved that equation for x, or whatever variable you used, you should be able to answer your question on minimizing or maximizing something. All right, so the big thing here is step 4, that you are going to have to express this function in terms of just one variable. And you'll see that a little bit more as we get going. Like, for example, what if you have area equals length times width? Well, both things in here, you can't use both of those variables like that. You have to have one expressed in terms of something else. So in other words, like you would have to have the area in terms of width, and then the only thing that you can have over here are W's. You can have no L's. Let's look at our first problem together. Take a minute, pause the video, and then we will read it together, underlining some important information. A 216 square meter rectangular pea patch is to be enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? That's my first question. And my second question is how much fence will be needed? So we know some things. This is 216 square meters and it is rectangular. So we have the area of a rectangle and it is 216 square meters. We also know that area is length times width. So this pea patch is enclosed by fence, and it's divided into 2 equal parts by another fence parallel to one of the sides. So let's draw some pictures here. So it could look something like that, or it could look something like that. But we know that we have one rectangle divided into 2 equal parts. So I have drawn the rectangle that we are going to look at right here. And let's take the information that we know so far and let's call this our length. So we have another one of those over here. And let's call this and this and this W. And let's take a minute and let's look at our problem again and see if there's any other information in there that I know. I know it's a pea patch. I don't really care what it is right now. I know I have fencing. I know I have a rectangle. I know the area of that rectangle. I know it's divided into 2 equal parts by a fence that's parallel to one of the other sides, as opposed to like diagonal or something. So I really don't think that there is anything else that the problem tells me. However, would you guys agree that okay, I kind of want to call it perimeter, but let's make sure you understand what I mean. I'm talking about the fencing. So would you agree that that perimeter is 3 of the W's plus 2L? Everybody comfortable with that, I hope? All right, so that's kind of like one more thing that I do know. And I really think that's it. So let's read the question. First one says, what dimensions of the outer rectangle will require the smallest total length of fence? So you need to understand when you read this that they are asking you to minimize the amount of fencing, which we are calling our perimeter. So we need a function, I'm going to put it down here, P of something. That's what I am trying to minimize, my perimeter or my fencing. So let's think, what can we do here? I need something that talks about these 2 different variables, but making them into one variable. So let's go back here for a minute. You guys comfortable that the area was 216 square meters? And if area is length times width, 216 would be equal to length times width. All right. I can solve for one of these 2 variables in terms of another one. So let's solve this equation for L. I'm going to divide both sides by by W, and I would get 216 over W is L. That means then that I can use W's in my function. So my function from here would be 3W plus 2L, and L is 216 over W. You have just done something practically miraculous. You have written a function in terms of one variable that you can figure out how to minimize this amount of fencing by using your calculus and a derivative. So let's simplify this function. This would be 3W plus, distribute here, and I would get 432, but instead of over W, I'm going to write this as W to the negative 1 because I want to be able to take the derivative. Remember, what I'm getting ready to do here is take the derivative and set it equal to 0, and that will give me W with the smallest amount of total fencing. So first step, find the derivative. That's going to be 3. Derivative of 432W to the negative 1 would be negative 432W to the negative 2. All right, I need to write the important information that I have on the right of the screen over here. So I'm going to write that L is equal to 216 over W, and I'm going to erase all the rest of this so that I can use this side of my iPad. My job now is to take this derivative and make it pretty, which means that I need to write it as one fraction. So I have 3 minus 432 over W squared. Getting a common denominator will give me 3W squared minus 432 over W squared. I can now set both the numerator and the denominator equal to 0. Let's factor out a 3 here. I'll get W squared minus 144. So 3 times W plus 12 times W minus 12 equals 0. So W would equal negative 12, W would equal 12, and W would equal 0. All right, let's think about those numbers we got when we solved. Remember what W is. It's the blue in the picture. It's the width. It can't be negative, and it can't be 0. So therefore, W would be 12. And if W is 12, L would equal 216 divided by 12, or 18. So let's look back up at question 1 here in my problem. What dimensions for the outer rectangle will require the smallest total length of fence? Well, that will happen when my length is 18 meters and my width is 12 meters. Those would be the dimensions that will require the smallest total length of fence. Question 2 was how much fence will be needed. So again, let me do some erasing here and talk about how I can find the amount of fencing needed. Do you remember that was our equation 3W plus 2L? So the amount of fencing I'll need will be 3 times 12 plus 2 times 18, which is 72 meters of fencing will be needed. All right, next problem. A rectangle has its base on the x-axis and its upper two vertices on the parabola y equals 12 minus x squared. What's the largest area the rectangle can have, and what are its dimensions? All right, please stop the video and read the question at least probably 2 more times. So let's do the whole what do I know again. I know I have a rectangle, and its base is here on the x-axis, and its two upper vertices are on this parabola that you see here, the y equals 12 minus x squared. So let me draw in a couple of different rectangles. This rectangle meets the qualifications. It has its base on the x-axis and its upper two vertices on the parabola. Let's draw in another one. Let's draw in this one. There's another rectangle with its base on the axis and its two upper vertices on the parabola. Do you see that I could also draw in a super skinny rectangle that's super skinny and super tall? And that would fit my criteria. So I'm just going to leave the blue one here that you see on the screen. So let's go back to what do we know. We know it's a rectangle, and we know its vertices are on the parabola here that I have written down on the right, y equals 12 minus x squared. There's really nothing else that I know. So let's look at my questions. What is the largest area? So I am looking here to maximize my area. So I also know that the area of a rectangle, again, is length times width. I'm also supposed to find the dimensions of that largest rectangle. So let's do some labeling on my rectangle. Would you guys agree that for this distance right here, that is some y distance? Here's some point on my parabola, and again, here's my parabola, y equals 12 minus x squared. And this distance here would be some x. That means that this distance right here is 2x. This would be my width, and this would be my length. So if my width is 2x and my length is y, are you all comfortable that I could set up, remember I'm trying to maximize my area, an area function in terms of either x's or y's? Well, let's think about this. I need a length times a width. Well, I've got the width. That could be 2x. And I have y. Y is 12 minus x squared. So I have set up a function in terms of one variable, only one. I know that to try to maximize this area, that I need to take this derivative. I do not want to use the product rule, so I'm going to distribute and get 24x minus 2x cubed. Now I can easily take the derivative, and I will get 24 minus 6x squared. Let's go ahead and factor the 6 out. That would give me 4 minus x squared, which would be 2 plus x, that quantity, times the quantity 2 minus x. So there's my factored form of my derivative. I can now take those two factors, set them equal to 0, so x would equal negative 2, and x will equal 2. Please look at the results that you got and think you cannot take this negative 2 and plug it in for x in your width, because if you do that, you'll get a negative width. No such thing. So according to my length is y, which is 12 minus x squared. So my length would be 12 minus 2 squared, or 8. My width is 2x, which would be 2 times 2, or 4. Please notice that you are given no units. So my width here would be 4, and my length would be 8. That answers part 2 of my question, but what about part 1? What's the largest area the rectangle can have? Well, the largest area the rectangle can have would be 8 times 4, or 32 square units. Hope you're comfortable with this one. On to the next problem. Let's read this one together. Suppose that c of x equals x cubed minus 20x squared plus 20,000x is the cost of manufacturing x items. Find a production level, means a number of items, that will minimize the average cost of making x items. All right, please read the question again yourself. Okay, now that you have paused the video and read the question a couple times, let's think about what we know. The first thing that should really excite you is, hey, they gave you a function. That's awesome. So let's talk about what the variables in that mean. C of x and x, what do they represent? Well, it says that C of x is the cost of manufacturing x items. So x is the number of items produced. So that's one of the things we know. And there's really nothing else we're told in the first sentence. We are supposed to find a production level, so that means a number, x. What is it? That will minimize the average cost. All right, we know we're minimizing something that has to do with cost, but please notice that we are minimizing the average cost. All right, let's think about what you guys know about an average. Think about your test scores in your calculus class. To figure out what your test average is, you add up all the tests that you have and you divide by the number of tests you have taken. That's how you find an average. The C of x that I am given up here, it doesn't say it's the average cost of manufacturing the items. It says that it is the cost. So to find the average cost, I'm going to call that A. It's the average cost of manufacturing X items. I would need to take my function and divide by the number of items produced, which is x. That's how you find the average. So this function would simplify to x squared minus 20x plus 2,000. Did I get that wrong? 20,000. All right. So, again, you know the cost function. You are creating the average cost function. You need to minimize this function. To minimize or maximize something, you take the derivative and you set that equal to 0. So my derivative is very simple. 2x equals 20. Factor that, so 2x, 2 times the quantity x minus 10. And I take that derivative and I set that equal to 0. And I come up with x is equal to 10. X is the number of items produced. And I am supposed to find a production level. That's what I have found. So my answer would be a production level of 10 items will minimize the average cost of making X items. Okay, here is the hardest problem in this optimization lecture. It's one of your homework problems. It says that you operate a tour service that offers the following rates. It tells you the rates, and then the sentence after that tells you the costs, and the sentence after that tells us what we're supposed to do. So pause the video, read the question multiple times, and then let's come back and talk about it. If I were with you in class, I would pick a student and tell them that they are the operator of the tour service. And then I would ask them to pick a location for this particular tour. But since we're not in class, I am going to pick some names, and a name and a place. So Trevor, you operate our tour service. And our tour service is taking and organizing a trip to Disney World. And we're going to Disney World because Dalton didn't get to go there. So here we go. The tour service offers the following rates. $200 per person if 50 people, the minimum number to book the tour, go on the tour. So we know multiple things. We know 50 people is the minimum number of people to go, or Trevor won't take everybody to Disney World. We know that the cost per person, if we have 50 people go, is $200 for each person. Then we're told that each additional person, up to a maximum of 80 people total, the rate per person is reduced by $2. So this sentence tells us multiple things. It tells us that 80 people is the total number of people that are allowed to go on this tour. And it also tells us that each person above 50 people that go will help offset the cost by $2 for all of the people going on the tour. So, for example, and I'm going to do this problem on multiple pages. So if the number of people that go is 50 people, then the cost per person would be $200. And you guys know that to figure out how much revenue that Trevor would make, we would need to multiply 50 times 200. So let's say that Trevor can get another person to go on the tour. Then the cost per person is going to be $200 minus one more person who is helping to decrease the ticket cost for everyone by $2. So now everyone on the tour, all 51 people, would only need to pay $198. So we know that this would be 51 times 198. Now let's suppose that Trevor can get 52 people to go. The cost per person now goes down because we have two $2 reductions. So the price of the ticket for everyone is now $196. So Trevor would get 52 times $196 per person. And I could increase this, and you guys try to write down what you think you're going to get if 53 people go. Take a second and write it. Did you get 200 minus 3 $2 reductions, or $194? And this is going to continue, this pattern, all the way up through 80 people, which would be 200 minus 30 additional people, helping offset the ticket price by $2 per person. And I really even don't care what that amount is right now. This is not that important to me. It's the process here that I want you guys to understand what's happening. Now, let's talk a little bit more in depth about this before we go on. Do you understand that this number is varying right here? And so is this number right here. The 1, 2, 3 all the way up to 30. And here, the 1, 2, 3 all the way up to 30. Everybody comfortable with that? It's really important that you understand what is changing here, what's varying. And think about it, what do we call something that's varying? We call it a variable when we set up our function. All right, let's go on and back up to our problem here and make sure that you guys understand that this is what tells Trevor his revenue and that this is what tells Trevor his expenses. It costs $6,000, a fixed cost. That means it doesn't change whether 50 people go on the tour or 80 people go on the tour. It is a fixed cost of $30 per person to conduct the tour. Excuse me, $6,000, a fixed cost, whether 50 people go or 80 people go, plus $32 per person to conduct the tour. How many people does it take to maximize your profit? All right, profit, profit, profit. Let's go to the next page and talk about what this would look like. Guys, profit would be the money Trevor has coming in from his tickets minus his expenses. So let's work on each one of these things, setting up an equation for it, because I know that I need to maximize my profit. So let's see if we can figure out a name for my variable, which I'm going to let be x. Let's go back a minute. when you look at this page, remember what was varying. It's the number of people above 50, and it's also the number of $2 reductions. The number of $2 reductions. So X could be the number of people above 50. And you can also think of this as the number of $2 reductions. So revenue. Let's figure out how to find that. Again, let's go back to our previous page. Guys, revenue right here. It was the number of people times the cost per person. The number of people times the cost per person. So the number of people going times the cost per ticket per person. So let's see if we can set up a function in terms of X for my revenue. The number of people going is 50 plus something, because you guys agree minimum number of people that can go is 50. And then I could say that the number of people above 50 is X, or 1X, times the cost per person. Look back at the previous page. Isn't that 200 minus 2? And this is the number of $2 reductions. So this is a gain of one person, every one person above 50, and this is the $2 reductions. So you could figure this out for 3, so let's just do this real quick and then erase it. If we have 3 more people going, I would put a 3 in for every X. So that would be 53 people going times 200 minus 2 times 3 would be 190. Whoa, let's try 194. Remember this? 53 people, $194 per person. Write down what you need, because I'm getting ready to erase this one. I guess you can go back and rewind, never mind. Okay. So I am assuming that you guys can distribute these 2 sets of parentheses right here and simplify that. And when you do that, you will get 10,000 plus 100x minus 2x squared. So that's my revenue function. All right, let's talk about expenses. Expenses are the fixed cost plus $32 times the number of people going. Everybody comfortable with that? If you're not, flip back in the video to where you can see the problem again. So my fixed cost is 6,000 plus 32 times the number of people is 50 plus 1x. So when I simplify this equation and do all the algebra, I would get 7,600 plus 32x. So this is my expense function. Up here at the top, remember that my profit function is my revenue function minus my expense function. Profit was revenue minus expenses. When I simplify this function, I get negative 2x squared plus 68x plus 2,400. All right, I'm going to erase everything on the page and then write our function back up the top and continue from there. So our profit function again was negative 2x squared plus 68x plus 2,400. I am trying to minimize this function, which means I need to take the derivative, which will give me negative 4x plus 68. I'm going to factor out the negative 4, which leaves me x minus 17. And I'm going to set this thing equal to 0, which will give me x is equal to 17. Now think back about what we had written about what x was. It was the number of people above 50 going on the tour, as well as the number of $2 deductions. I was supposed to find the answer to this question. How many people does it take to maximize your profit? So 50 people plus the number of people over 50 would be 67 people to maximize the profit. Now, 2 what-if questions. What if I was asked to find the rate per person that maximizes the profit? Wouldn't that be 200 minus 17 $2 reductions, or $166 per person? And what if, number 2, I was asked, what is the maximum profit? Because Trevor wants to know how much money he can make when he gets to go to Disney World and take Dylan. So the answer to that question would be P of 17. So when you go back to your profit function up here and put in 17, $2,978. Well, you have successfully done the hardest problem here. So let's look at 2 more that have to do with some engineering questions. Designing a tank. Your ironworks has contracted to design and build a 500 cubic foot, square-based, open-top, rectangular steel holding tank for a paper company. Did I skip a problem? Let me look. Yep, I did. All right. We're just going to do this one next because it's next in your notes, and then we'll come back to the other one. Sorry about that. Designing a box with a lid. A piece of cardboard measures 10 inches by 15 inches. 2 equal squares are removed from the corners of a 10-inch side as shown in the figure. 2 equal rectangles are removed from the other corners so that the tabs can be folded to form a rectangular box with a lid. Okay, please pause the video and read the question again. All right. So by now you should understand that you have a piece of cardboard that is 10 inches on one side and 15 inches on another side, and that we are cutting out 2 little squares from the 10-inch side and 2 rectangles from the longer 15-inch side. Now, let's get rid of everything here, not like that. And let's imagine folding up this box. Fold it along the dashed lines in your head. Fold up these 4 little pieces first. You've now got a box with sides, and then flip the lid over on top. Everybody visualize how this is forming a box? All right, let's look at what we're supposed to do. I'm going to get rid of some things here that you are not responsible for. So we need to write a formula, V of x, for the volume of the box. So if we do exactly what they're asking us to do, what's the formula for the volume of the box? Find the domain of V, in other words, what can x be? And then find the maximum volume of the box and the value of x that gives that. All right, let's start by recalling that a volume of a rectangular solid is length times width times height. So L is length, W is width, and H is height. Now look back at your box a minute. If I fold that box up, and this is X right here, then would you agree that the height of the box is H? Everybody got that? Now let's pick a different color, and let's talk about this dimension right here, this 10 inches. Would you agree that it's made up of this length plus this length plus this length right here? So 10 inches has to equal an X plus a, what's that, guys? Let's call that L for length plus another X. So 10 is equal to 2X plus L. Let's do the same thing with the 15 inches here. Do you see that 15 is equal to an X and an X? So 2X. Let's call this W, the width. So what does that make this dimension right here? Do you see that it's also W? So 15 would have to equal 2x plus 2w. All right, I want to maximize the volume, which means that since h is x, I need to write a volume in terms of x problem. So I need to take both of these two equations here and solve them for L and for W. So L would be equal to 10 minus 2x, and W would be equal to, well, let's do 2W, would be equal to 15 minus 2x, or 15 halves minus x. So if the volume is length times width times height, that would be 10 minus 2x times 15 halves minus x, that's my width, times x for my height. When I simplify that algebraically, I end up with 2x cubed minus 25x squared plus 75x. Just to let you guys know, I distributed the x first, and then I did FOIL. Alright, so we have done part A. We have written a formula for the volume of the box in terms of x. Part B is asking me to find the domain of V in the problem. In other words, they're really asking me, how much can I cut out for x, for the little squares and for the rectangle? So let's think about this. Both the length and the width, both the length of the box and the width of the box need to be positive or greater than 0. So that means that both 15 halves minus x has to be greater than 0, and 10 minus 2x has to be greater than 0. The second one is super easy to solve. We would come up with x is less than 5. Up top, I would get x is less than 15 halves, so I'm going to write that as 7.5. All right, let's erase a couple things here for a minute. So that I can refer to my picture. Guys, why in the world does x have to be less than 5? Well, let's think about it. If I cut out from this 10-inch side 5 inches from that side and 5 inches from this side, guess what? I have no box. And the same thing here. If I am cutting out on this 15-inch side, 7.5 inches here and 7.5 inches here, there is no box. If I look at my domain values, x has to be less than 7.5 and x has to be less than 5. The more restrictive domain is that x has to be less than 5. So for this problem, my domain is from 0, not inclusive, because if I don't cut out anything, I can't make a box, up to 5, not inclusive, for the value of x that I can cut out. So part B is done. Part C asks us to maximize this volume function here and find the value of x that gives that. And to do that, I simply need to take the derivative of my function, which would give me a 6x squared minus 50x plus 75. And that thing will not factor, no GCF. It won't factor, the trinomial doesn't factor into the product of two binomials. So I would need to use the quadratic formula, which I am assuming that you guys remember. And when you plug in and simplify before you find the values, you would get here. And when you solve this, the two values that you get are approximately 6.3 and approximately 1.96. Now, please notice that 6.3 is not in my domain, so I can't use that. So to maximize the volume, I need to use a length here that is 1.96 inches. And to figure out what that volume is, I need to plug that value in to my simplified volume function, and I get out 66.02, and my units are cubic inches. All right, let's go back in your notes, which would mean I'm going on to the next page, which would be designing a tank. This is our last problem. Your ironworks has contracted to design and build a 500 cubic foot, square-based, open-top, rectangular steel holding tank for a paper company. The tank is to be made by welding thin stainless steel plates together along their edges. As the production engineer, your job is to find dimensions for the base and height that will make the tank weigh as little as possible. What dimensions do you need to tell the shop to use? Please pause the video and read the question at least once, probably twice, to yourself. All right, I have drawn a sketch of a square-based, open-top, rectangular steel holding tank. So let's figure out what else I know. If I am told 500 cubic feet, then I know that I'm given a volume because of the units. And I know that volume is length times width times height. Now, I also know that the bottom is a square. So if I call this L and this W and this H, I know that L is equal to W because it has a square base. I'm going to go ahead and call that X. Now let's look and see if I know anything else before I start looking at my question. 500 cubic feet, square-based, no top. So would you guys agree that this thing has a base and 4 sides? And I know that it's rectangular. So that means that the sides are rectangles and that the base is a square. And as I read, there is nothing else that I think that I know. So we are supposed to find the dimensions for the base and the height, so length times width and height, that will make the tank weigh as little as possible. So I am trying to minimize the weight. All right, let's think about that a minute. If you were trying to minimize the weight, does it make sense to you guys then that you are trying to minimize, the surface area? Less surface area I have, the less it'll weigh, this tank. So let's see if we can figure out how to do that. I need to minimize my surface area. That's the formula that I'm trying to come up with. A surface area formula in terms of x. Well, I have, like I said, 4 sides, and they're rectangles, and I have 1 base, and it's a square. But I need this in terms of x's, so length and width times height, they're going to have to come into play. Guys, you comfortable that, oops, let's make that a 500. You guys comfortable that 500 would have to equal L times W times H? And I know that L and W are both X. So, hey, look, I can express H in terms of X. And remember, over here for surface area, I'm going to be using X's, not L's and H's and W's. So H would be 500 over X squared. All right, let's work on my surface area a minute. I need to do 1 base plus 4 sides for my surface area. Remember, we're talking about surface area here. So the base would be the length times the width, or in this case, x times x, or x squared. I have 1 of those. I have 4 sides. So let's figure out how they're going to be represented. All right, let's look at one. One of them would be here. This would be the front and the back. Do you agree that it would be H times W, which is H and W? And then let's look at this side right here. So right and left, wouldn't that be the height times the length? And isn't this the height and that the length? So wouldn't I have, for the surface area of my sides, 500 over x squared times x? Again, this is the height, and this is either L or W, depending on which side you're looking at. So let's go and simplify this equation. So surface area in terms of x would be x squared plus 2,000 over x, because this divides out with one of those. I need to get a common denominator. So well, no I don't, because I can write this as 200x to the negative 1. So let's go take the derivative next, which would give me 2x minus, whoops, did I lose one of my zeros here? Yep, let's fix that now. So you guys comfortable? This would be 2,000x to the negative 1. So my derivative would be minus 2000x to the negative 2. So my surface area derivative would be 2x minus 2000 over x squared. Get a common denominator. This would be 2x cubed minus 2000 over x squared. I'm going to factor a 2 out of the numerator. Over x squared. And I need some more room, so I'm going to erase Alright. So I can continue to factor. Well, I really don't need to, I guess. Let's just set this derivative, the numerator equal to 0. And the denominator equal to 0. Well, my height can't be 0, so I know that's out. So here, divide both sides by 2. So x cubed will equal 1000, so x will equal 10. All right, go back, think about what x is. X is the length and the width. So the length would be 10, the width would be 10. To figure out the height, I'm doing 500 over 10 squared, or 500 over 100, which is equal to 5. Make sure you've answered your question, which says, your job is to find dimensions for the base and the height that will make the tank weigh as little as possible. So my answers are 10 feet by 10 feet for the base, by 5 feet for the height. And you are done, finally, with the optimization video.